Hello friends, welcome to SIVARAJAVEL IAS Academy, and this is our weekly current affairs update session with respect to environment and geography. In today's session, we will discuss about an important event which has happened recently called as Tonga volcanic eruption. So it has been regarded as one of the strongest volcanic eruptions which has happened in the recent times. And the exact place where this volcanic eruption had happened is somewhere in the midst of Pacific Ocean, right? Pacific Ocean, that is to the eastern side of Australia and to the northern side of New Zealand. So it is a isolated island which is present along the plate boundary of Pacific region, and it has experienced a huge volcanic eruption, and the volcanic eruption resulted in the expulsion of larger amount of plumes and gases which might have greater impact on the environment as well, right? So this Hunga Tonga volcanic eruption is regarded as a submarine volcanic eruption. That is, the volcanic eruption has happened from the bottom of the ocean, and its eruption resulted in the explosion of gases to the entire region in and around the Pacific Oceans. Then it has also triggered an earthquake and powerful tsunamis in the nearby regions of Pacific coastal countries, right? So let us understand what is the reason behind this region to experience such an active volcanic eruption, and how far it is related to the conventional earthquake and volcanic prone regions of the Pacific Ocean, and what is this specific submarine type of volcanic eruption is happened in this particular region, right? So we will discuss all of these things in detail. So if you observe the position of this Tonga volcanoes, it is pointed somewhere here, right? That is in the plate boundary region of Pacific Ocean, right? So this entire region is called as Pacific Ring of Fire. That is the border regions of Pacific Ocean and the nearby coastal regions of all the North American and South American, as well as the Eastern Eurasian regions, right? So this is regarded as the world's most volcanic erupted region, as well as around 65% of world's earthquake and volcanoes are happening in this particular region. It is because of this active volcanic eruption this entire region is called as Pacific Ring of Fire, right? Let us understand why this region is highly prone to this volcanic eruption as well as earthquake. Then it is one of the highly tsunami prone regions of the world, right? If you observe the position of this Pacific Ring of Fire, you can easily associate with the tectonic plate boundary region, right? So it is the region where the convergence of the oceanic portion of a larger ocean or a continental plate along with the larger Pacific oceanic plate. So the larger Pacific oceanic plate, which is regarded as a complete oceanic plate, which has a striking effect with every corners in and around the regions, right? So how come this convergence of plate tectonics had resulted in the expulsion of volcanoes, as well as these regions are known for tsunamis as well as earthquakes, right? So we need to get an idea from where the tectonic plate interactions are happening, right? So if you observe a region where a oceanic plate and oceanic plates are normally diverge from each other. Divergence means that is moving away from each other. The divergence of two oceanic plates allows the lower lying molten magma which is present at the upper portion of the mantle regions, which is otherwise called as asthenosphere, to erupt upwards, and finally once it reaches the outer surface of the ocean, due to the reduction of temperature, these volcanic erupted magma will be converted into solid rock-like structures, which paves the way for emergence of mid-oceanic ridges. So mid-oceanic ridges are landforms which are created on the divergence of two oceanic plates. You can easily observe the larger presence of mid-oceanic ridge in the central region of Atlantic Ocean. In the same way, if we take the case of a convergence of two continental plate, that convergence of two continental plate, where the larger size of continental plate normally does not result in the subduction of one plate below the another plate. So most probably it would be resulted in the formation of fold mountains wherever the convergence of two continental plates are taking place. But if you take the case of the convergence of a oceanic plate along with the continental plate, especially if you take this particular region where the oceanic plate are converging with the continental plate, here you can easily observe that it is because of the higher density and low thickness, oceanic plates are subducted below the continental plate. The subduction allows the portion of the oceanic plate to enter into the molten magmatic region of asthenosphere, which would resulted in the eruption of molten magma to the outer surface of continental regions. So wherever you are finding the convergence of two oceanic plate with the continental plate, either it could have resulted in the formation of volcanoes on the continental margins, or sometimes it would resulted in the formation of fold mountains also, as in the case of Rocky Mountains of North American region as well as Andes Mountains of South American continental regions, right? On the other side, where the oceanic plate are subducted below the continental plate, you can easily observe this region to be experiencing the trench-like formations. So trenches are formed on the oceanic side and volcanoes or fold mountains are formed on the continental side. These are all created as a result of ocean continent convergence. But the major convergence when two oceanic plates are converge with each other. So as a result of lower thickness when compared to the continental plate, both of these oceanic plates are comparatively low in thickness. But one oceanic plate, due to its higher density or higher velocity, when it subducts below the another oceanic plate, it would result in the formation of molten magmatic eruption over the another plate. The region where it subducts, it would result in the formation of trenches, right? So the same trenches which are formed on the oceanic margins along the continental regions is also been resulted in the formation wherever the two oceanic plates are converged with each other. On the another side, where these molten magmas are erupted, it would result in the formation of volcanoes, and the continuous regions where these ocean boundaries, the plate boundaries are extending, you can find the presence of larger presence of continuous chain of volcanoes over there. When it erupted and when it builds upwards, that is when it get builded up beyond the surface of the ocean regions, it would result in the formation of islands, right? If it is an active convergent plate boundary, it is always known to have the active volcanic eruptions in those regions, right? So wherever you are finding the convergence of oceanic plate with oceanic plate with oceanic plate, it would resulted in the formation of trenches, volcanoes, right? And the region where the subduction is taking place, you can also experience a high intensified earthquake over there. So earthquake and volcanoes are closely associated with each other wherever the convergence of two oceanic plates are taking place. The earthquake which triggers a higher energy to the surface level of the bottom of the oceans would also be resulted in the formation of high waves which are otherwise called as tsunamis. So volcanoes, earthquakes and tsunamis are highly related to the active ocean plate boundary interactions, right? So if you observe this map, you can easily find that the oceanic part of Indo-Australian plate, when it converges with the oceanic part of Pacific plate, it would resulted in the formation of trenches as well as active volcanoes over there, the Tonga regions, right? And in the same way, you can find the Mariana Trench, Kuril Trench and Aleutian Trench. All of these are found along the margins of the oceanic regions where these convergences are taking place, right? So this entire region of Pacific Ocean boundaries are known for high presence of active volcanoes and earthquakes, which is also the reasons for high tsunami prone regions of the world, right? As I said before, it is accounted for 65% of world's most volcanic and earthquake prone regions, right? So this Tonga region where there is recent volcanic eruptions are taking place is found in as a part of this Pacific Ring of Fire, where Australian plate which is interacting with the Pacific plate are taking place, right? So this is the basis behind the region which is known for high volcanic eruptions, right? So on the basis of this, if we observe the presence of this Tonga region, the Pacific plate which is subducting below the Australian plate, both of these are considered to be the oceanic plate. On one side, it would resulted in the formation of Tonga Trench and Kermadec Trench, which are found along the eastern margins of these plate boundary regions, and it also resulted in the eruption of molten magma to the outer surface, which itself been converted into the formation of volcanoes, and the continuous chain of these volcanoes are called as volcanic islands, right? When the active convergence are getting diluted, these active volcanoes in the future may convert themselves into an islands, right? And this region where this subduction, that is one plate is submerged below the another plate, is also known for high earthquake activities, right? So you need to understand the plate tectonics, especially the convergence of oceanic plate, that is convergence of oceanic Australian plate along with the oceanic Pacific plate would be resulted in the formation as well as eruption of volcanoes over this particular region. But if we observe this particular eruption, it has been regarded as submarine volcanic eruptions, right? It is normally differ from the other volcanic eruptions which are normally taking place in this Pacific Ring of Fire region, right? This submarine volcanoes, that is, these volcanoes are not exposed to the outer surface. These are normally found at the bottom of the ocean bed itself, right? Normally, when the magma are erupted from the when the magma are erupted in the regions where these volcanoes are formed, it normally has a temperature of 1200 degrees Celsius, right? But this eruption normally taking place at a slower phase, as we have observed in the mid-oceanic regions. When these molten magma are exposed to the outer surface of the ocean, I mean the bottom of the ocean, due to its interaction with the ocean water, it gets solidified and converted into another landform, right? So normally, whenever these volcanic eruptions are taking place at a slower phase, a film of steam would form between the erupted molten magma and the water which are present over there. So this act as an insulating medium, right? The steam would act as an insulating medium so that it allows the molten magma to get solidified in a slower phase. So slower solidification of molten magma would take place, which is normally happening over there. But in this case where the rapid eruption of volcanic magma at the bottom of the ocean doesn't allow this insulating medium of steam to get formed, so that directly these high concentrated or highly effective these volcanic magmas are directly getting contact with the water which are present at the bottom of the oceans, would make it to be considered as a fuel coolant interactions. This is otherwise called as fuel coolant interactions, right? So normally when this quick interaction between the hot magma and its contact with the cold water, it would resulted in the explosion which might be equivalent to a chemical explosions of weapons grade. So a larger, a rapid eruption of this molten magma and its interaction with the cool ocean waters of the above regions would resulted in numerous highly effective explosion kind of activities, which is technically called as fuel coolant interactions, right? So this volcanic explosion or volcanic eruptions is traditionally not related to the way on which these normal volcanic eruptions are taking place over these plate boundary regions, right? So as I said before, this volcanic eruption is present in the region of Pacific Ring of Fire regions, so that these volcanic eruptions is also associated with the earthquakes. Earthquake of 5.8 Richter magnitude level have been observed in this particular region of Tonga region, as well as it has triggered the sudden eruption of these volcanoes have triggered the tsunamis to get generated, and the effect of these tsunamis have been observed in every corners of the Pacific Ocean, right? In every corners of the Pacific Oceans, right? Even our IMD have recorded certain effects of these volcanic eruptions, right? 1.2 meter height tsunamis have been observed normally along the coastal regions of all Pacific regions, right? So tsunami which had heavily damaged the regions of Hunga and Tonga in this particular volcanic eruption. So already it has been hit with earthquake as well as tsunamis, right? So even the Japan, USA, coastal regions of Chile are experiencing an unusual kind of rising waves, which is otherwise called as tsunamis, at the time when this Tonga volcanic explosions are taking place, right? So earthquake, tsunami, as well as submarine volcanic eruptions are taking place as a result of these activities, right? So the volcanic gases which are exposed to the atmospheric level as a larger plumes of magma would also have a high detrimental effect on environment as well. It has been considered as these volcanic gases have extended up to 35 kilometers in the higher atmospheric level. It has entered into the stratospheric region, right? It has entered into the stratospheric region, where some of the scientists have predicted that it might have the capacity to reduce the temperature of the earth for next few years, right? So around a minor level of decrease in temperature, because these gas fumes, when it is present over the stratosphere, it can act as a filtering agent, or it can act as a barrier to the incoming solar radiations, which might have reducing the overall temperature of the earth, right? But these gas fumes which are spread across numerous kilometers in and around these Tonga regions are settled on the surface itself. These can be regarded as ashfall. This ashfall have numerous environmental damages, especially the crops and livestock are greatly affected as a result of this ash conditions which are present in the entire regions of Tonga, right? Which would definitely affect the livestock as well, right? And another important concern with respect to these volcanic eruptions are having the capacity to release two important gases along with its explosion, that is sulfur dioxide and nitrogen oxide. When these two gases, that is sulfur dioxide and nitrogen oxides, are combined with each other, it has a potential for creating acid rain, which further affects the crops and other related activities, right? And obviously the health of these peoples would also be highly impacted as a result of these polluted gases and other and other gas fumes which are released as a result of this volcanic eruptions. Already this region is known for larger coral bleaching activities, right? Coral is one of the most sensitive marine organisms, which when the symbiotic relationship of both polyps and zooxanthellae. Zooxanthellae is a kind of algae which can create its own food, and polyps are secreting this calcium carbonate kind of materials, where both of these are having a symbiotic relationship of each others, right? So due to numerous effects as a result of pollution or global warming or ocean acidification, coral bleaching is taking place at a larger scale in the regions of Pacific Ocean as well. Now these volcanic ash, when it is fallen on these already depleting coral reefs, it might affect the further growth of these coral reefs. Already coral reefs are highly affected in these regions, and these volcanic ashes, when they are fallen over these coral reefs, has the capacity to bury themselves under the bottom of the oceans itself. So it can be regarded as the most potential organism of the entire marine ecosystem. So we might have either in a short span or for a long span, these the environmental impact of these volcanic eruptions are going to be high on every aspects, right? So these are all the certain details with respect to the recent activity of this Tonga volcanic eruptions, right? Next, on the same scale, if we observed the recent phenomena of Myanmar earthquake which had happened in this particular region, of India-Myanmar border region, right? So very closer to the border regions of India, especially in the northeastern regions, the effects of this earthquake, it has been regarded as 5.4 level of a 5.4 Richter scale of magnitude level have been observed in this particular earthquake phenomena, right? But it has taken place at a very deeper level of 58 kilometers. The focus of this earthquake had originated in 58 kilometer bottom of the surface. So it might not have created so much impact on the surface level, right? Why this particular region is also known for high earthquake kind of activities? Again, it is also related to the convergence of plate tectonics. If we have observed the plate tectonics, the Indian plate that is Indian plate is nowadays have been called along with the Australian plate, where it is regarded as one of the major tectonic plate. Indo-Australian plate has been called as one of the major tectonic plate. Within the Indo-Australian plate, Indian plate was once upon a time was attached to the Gondwana land of India, Gondwana region of the entire world, right? So Gondwana are southern plates, and Angara or Laresh are considered to be the northern plates of once upon a time it was regarded as Pangaea, right? So when Indian subcontinent or Indian plate was part of Gondwana, and it was attached to the African region, present day Africa and Madagascar, right? Indian plate was once upon a time was attached to the present day African continent, and it get detached from the African continent, and finally it is hitting the Eurasian plate. As a result of the collision of this Indo-Australian plate along with the Eurasian plate. It is also regarded as continent convergence, because Indian plate is a continental plate and Eurasian plate is also considered as a continental plate. As a result of this continent convergence, we have the presence of the largest fold mountains of the world, which is nothing but the Himalayas, right? So it is the active convergent plate boundary region, right? So the emergence of Himalayas is itself been associated with the convergence of Eurasian plate along with the Indian plate. So if you observe the position of Himalayas is itself taking a syntaxial bend at the northeastern portion of India, and again it is continuing in the form of Arakanyoma, and it is continuing in the form of Arakanyoma in the Myanmar regions, right? So the presence of Himalayas and the emergence of Himalayas is itself been associated with the active convergence of Indian plate along with Eurasian plate is one of the most potential region for occurrence of high earthquakes over this particular regions, right? So if you clearly observe here, the entire region where these Indian plate are collided with the Eurasian plate have resulted in the formation of Himalayas. And if you clearly observe the extension of this continental plate, when it is present over the Bay of Bengal region of Indian Ocean, you can easily observe that here the Indian plate are collided with the Burma plate. Burma plate is a separate plate, right? The collision of these both of these plates would have resulted in the formation of volcanic islands, as we have discussed in the Tonga case. These volcanic islands, when they have exposed to the outer surface of the oceans, it has been regarded as Andaman and Nicobar Island, right? So the present Andaman and Nicobar Islands are considered to be having volcanic origin, where the same phenomena which was the reason behind the formation of Himalayas is also been considered as the reason for the formation of Andaman and Nicobar group of islands, which further extends towards the Java and Sumatra regions of Pacific Ocean, right? So Indian plate's collision with Eurasian plate is one of the most potential region for high seismic activity or earthquake activity. If you have observed the seismic map of India, this entire northeastern region and the Rann of Kutch region of Gujarat, where the one end of Indian plate is attached with the Eurasian plate, and the another region where the syntaxial bend is taking place after it is collided with the Eurasian plate is also the two important high seismic activity zones of India. Then if you observe the other regions where this entire active convergence is taking place, you can easily find that these are all the regions of potential earthquake regions of India, right? And the active convergence of Indian plate along with Eurasian plate makes the entire Himalayan region as well as the Rann of Kutch region to be the most earthquake prone regions of India. In this particular region where we have observed, right, here is the location where the recent earthquake activity have been taken place, but it has taken place the focus or the origin of this earthquake have happened at a much deeper level, so that on the surface level we might not have so much damage as it has caused in the Tonga volcanic eruptions kind of things, right? So you need to understand how plate tectonics is associated with these important activities of volcanic eruption, earthquake as well as tsunami formation, right? So these are all the two important events which had taken place in the recent times, which have a close relationship with the plate tectonics, especially the ocean convergence with respect to Tonga volcanic eruption and the continent convergence with respect to the Indian plate along with the Eurasian plate, which have resulted in the Myanmar earthquake in the recent times. With this, we can wind up this session. Thank you, friends.